All right, we're ready to start. Thanks everyone for joining, and welcome to our webinar about troubleshooting Kubernetes-based applications, the 7 key components you need to have. And today we're also excited to announce that we're fully supporting Kubernetes, and that we'll also be attending KubeCon in San Diego next week. So if anyone is planning to be there, please stop by our booth and say hi. So let's dive in. Today in the webinar, I'm joined by Rich and Dave, who are our in-house Kubernetes experts. And my name is Alex, and I'm the Director of Product Advocacy here at OverOps. Rich and Dave, would you like to say a few words to introduce yourselves? Let's start with you, Rich.
Sure. Yeah. Hello, everyone. Yeah, my name is Rich Baruki, and as mentioned here, I'm a solution engineer. So anything around, working with OverOps with our customers and prospects to add value into their software delivery lifecycle. So it's good to meet with everyone, and I'm happy to chat with everyone today.
Thanks, Rich. Dave?
Yeah, so I'm Dave Snyder, integration engineer here at OverOps. As my title suggests, I build integrations between OverOps and all the third-party tools that you know and use every day, like Jira and Jenkins, TeamCity, also Docker and Kubernetes. So we just like to integrate all those things into OverOps to help to get OverOps to be a regular part of your workflow.
Perfect. Thanks, Dave. Another fun fact about Rich and Dave that you guys might know is that they really like questions. So please, if you have anything that you'd like to ask during the webinar, we'd like to keep it interactive. And again, this is a live webinar, so nothing here is pre-recorded. Every kind of slip-ups and mistakes we make are real. And yeah, so please use the question box on the right side of your GoToWebinar screen. And if anything comes up, we'll be happy to just quickly pause and answer your questions as we go. All right, so what are we talking about today? So Kubernetes is kind of being brought up as the answer to all life's problems, and this little comic strip kind of shows one funny way to look at it. And in this webinar, we're going to talk about actually the other side of the coin. So some of the challenges that are coming up with Kubernetes-based applications. So while there are a lot of benefits like faster deployment cycles and better separation of concerns, so teams can more easily work on the different microservices and help speed up development. There are also many challenges that come up, and one of them is troubleshooting, and we'll focus that today. So we'll start off with a quick Kubernetes and containers 101. We'll cover some of the basics that you might already know. Then we'll focus on the challenges of troubleshooting in Kubernetes-based applications. And we'll suggest a solution to that with the must-have elements of root cause, the pieces of data that you need to have to successfully troubleshoot issues in Kubernetes-based applications, and we'll finish with how OverOps can help you get this data and troubleshoot Kubernetes-based apps. All right, so let's start with the first part of this webinar, Containers and Kubernetes 101, and Dave from our team is gonna help us with this stage. So Dave, just kind of as a quick overview for everyone who's joining us today. So what is really a container?
Yeah, so hopefully, this is a call about Kubernetes, so we're all familiar with containers. But in case you're just getting started with containers and maybe you're still on a virtual machine, a container is really a standardized executable software package that contains all the code that you need and all the dependencies for that code, everything to run all in one package that can then be shipped around. It's lightweight, it's portable, it's secure. And this really makes it easier to deploy things like microservices. So in our diagram here, we have the UI of your product, which is reaching out, interacting with a handful of different microservices, which interact with each other, which interact with databases. And if you're trying to deploy this in virtual machines, it just gets really heavy really quickly. And so containers are really great for that sort of use case. So it's just a really small, lightweight, shippable piece of code. It's almost like an app, but it's running server-side code. So if you go to the next slide, Alex.
Yeah.
We have all these containers floating around, right? And that's great. But that's where Kubernetes then comes in, because when you start to have more than one container, really, you start to have tens or hundreds or thousands of them. You need a way to orchestrate these, to manage them, to maintain them. So that's what Kubernetes is. Kubernetes is a platform as a service and infrastructure as a service rolled up into one product. It actually operates at the container level and provides us a lot of useful facilities. So things like deployment and scaling and load balancing are all solved with Kubernetes and made a lot simpler. And fortunately, we can run almost anything in Kubernetes. So I mentioned microservices, but you don't have to run microservices. You could run anything you want. Anything that will run in the container will run nicely in Kubernetes.
Perfect. Thanks, Dave. And we have a quick question to the audience here. So if you can use the chat box, and can you tell us which stage in the Kubernetes journey you're in? Are you just learning about Kubernetes? Are you moving your existing application to Kubernetes or building new applications? So would be curious to hear. Thanks. I see already a few responses coming in. Got it. So see, most people are just learning. Some people are fully deployed. Yeah, so it sounds like the majority of the people we have on this webinar right now are in the learning stage or moving their existing applications to Kubernetes. Got it. Thanks for the participation, guys. All right, let's move on. So Dave, so what's the downside of Kubernetes? We've mentioned some of the benefits, but how does it look like from the challenges point of view?
There's definitely a lot of benefits, but really what we're doing is increasing the complexity of our system, right? So if you're used to deploying a single monolithic app and a few virtual machines, you really just have a couple places to look when something goes wrong. You probably have an error log or an access log, from your one or two applications, and that's basically it. But once we start to break things down into these microservices and we're deploying, tens, hundreds, thousands of containers, all of those have all of their own logs, and they all interact with each other. So I might see an error in one part of my system, which isn't actually caused by that part. It's caused by a service, 3 or 4 jumps down the stack. So now all of a sudden I have to find a way to aggregate all these logs across all my different containers. I have to find a way to trace through to find the real root cause of the problem. And ultimately, it just can become a real headache because of that extra complexity to drill down and figure out what the real root cause was. So fortunately, though, we do actually have a bunch of tools for this, which I think we cover next. Yeah, so for all of those of you who are already well on your way to moving to Kubernetes, you're probably familiar with all of these logos. So out of the box, Kubernetes comes with a lot of tools for logging, or things that play nicely with it, right? Things like Fluentd and Elasticsearch and Kibana can really help aggregate all those logs across all of your different containers into one place. Or we can use Kubernetes metric system to stream CPU usage and memory usage and those sort of metrics into Prometheus, and we can visualize those in Grafana to maybe have an idea of, is this node running hot or is this container running hot, and kind of figure out what's going on. And then if you're willing to take the leap to actually change your code, you can add tools like Zipkin, which will add headers to each trace, to each HTTP request, so you can actually trace through and figure out what's going on. To an extent, I mean, that adds more, everything adds more overhead, it adds more complexity when you're adding all these tools in. And Zipkin requires code changes, so that's kind of unfortunate. But with all of these tools, you can kind of almost get back to where we were before, which was like, oh, great, now I've got one place to look when something goes wrong. I can start going through those logs and figure out what was happening.
Thanks, Dave. And what really what makes this troubleshooting these applications really hard?
Yeah, so just again to kind of summarize, it's really just we've added so much complexity to our system. We have so many moving pieces that there are just more places to look. And so where before we might have had one place, now we have a lot of places. We have all these different logs. We have all these transactions flowing through different services. And it can just take a lot of time to get to the bottom of what's really going on.
Yeah, makes sense. And what are some ways that what's the most common way to identify errors in these types of applications?
Typically
How are
it's
these
the
errors
same.
are usually identified? Yeah. Mm-hmm.
Yeah, I mean, it's sort of the same in Kubernetes land or wherever you are, which is logging and alerting, tools like Splunk, PagerDuty, right? Things that can alert you that something has happened, and then you go straight to the logs and then try and work backwards to solve what happened, right? Those are the sort of tools that we have. Unfortunately, some, we have Kubernetes specific ones, but ultimately it's the same needle in a haystack problem where you've got to figure out, I have all this information, now what really went wrong? It's usually still on a difficult task to figure out what's really happening.
Yeah, makes sense. And I think we're also hearing a lot that even companies and engineering teams who use all of these tools, they still encounter a lot of problems, and their code still breaks. So for these types of issues that go through, we have the second part of the conversation, and the conversation we're having today is this 7 elements of true root cause. And thanks, Dave, for providing this intro about Kubernetes and some of its challenges. Now we're going to move on to the second part of the webinar with Rich. Mm-hmm. So Rich, let's assume we had it could be a customer that identified a user that identified an error in production, or one of the tools that were mentioned that was able to identify it before there was a customer impact. Once we have this error in our hand, what would be these elements that we need to consider when we're investigating the root cause of that issue?
Yeah, great question. Yeah, and that's what I really want to get into for the rest of the webinar, is really get into those 7 elements that you see here that we're showing on the slide, right? 7 elements of true root cause. And then what I'd like to do, Alex, is maybe get into a demonstration to how we can potentially access these particular elements and try to help to do that in more of an automated fashion. When we think about a very complex environment of potentially dozens, hundreds, or thousands of services that are being operated out of a Kubernetes cluster, right? And so let's go ahead and get into these 7 elements. I'll as I get into the demo, I actually have a bit of a bonus that we can talk about as well, but I'll hold that until the demo. But yeah, so when we think about application errors and being able to access what is really the culprit to application errors and why the application and system is breaking, it's comprised of some elements that we're going to describe. First and foremost, and I think much of us are familiar with, right, is understanding that call stack, or appreciating what the execution path is of our code at given time of the error and exception, so that we can have some type of breadcrumbs, if you will, to know, what services have been called, what methods, so on and so forth. And many times we get that from logs, and we write that to logs and what have you. So that would be one element to finding that execution path. Now, if we go ahead and play that forward, the next one is really appreciation beyond just that execution path, but rather it would be nice as a development team to understand and know what code was actually running. Now, you might be asking, how is that different than the execution path? But, really being able to appreciate the actual lines of code that was running at time of the exception or error or the problem that was caused in a application running on Kubernetes would be extremely valuable just to have that context, right? To know exactly, have confidence to know how the code was actually running as opposed to guessing or wondering how the code was running. All right.
Hey, Rich, I actually have a quick question about that.
Yeah.
Why is that even a problem? Why don't we already know which specific version of the source code executed?
Yeah, sure. So many times I think, and that's why I kind of delineate between the execution path, is we tend to have a tendency to think we know, right? Because we have that execution path. But as we're going to find later, we may find that the data that's being processed may not be calling a method that we had expected, right? And it goes to a path that and code was running that was unexpected per se, right? And so having that factual evidence of the code that was running specifically, I think will in turn be valuable when we cross-reference that with another one of our elements that we're going to describe, in particular, the line of offending code and the data that's processed as well. And we'll get into that here in a second.
Yeah, thanks, Rich.
Okay. Yeah, so playing it forward in, when we have a visual and it can look at something as the code that was running, very much like a debugger, it'd be very interesting to know the specific line of code that is causing the error or the offending line of code to really shine a light, much like we do in debug mode, in a development environment to quickly see what line of code where we're having issues. But I think probably most interesting enough is going beyond that, is getting into our fourth element to find true root cause of an application, is in being able to understand the data that has been processed by the code at times. So if we advance the slide there, Alex. Many prospects and folks that I talk to is, the biggest challenge of being able to troubleshoot applications, back it up to number 4 there, Alex, data and variables. Being able to describe what data was being processed at time of error or exception. And so, again, this goes beyond, thinking what the data might be doing or what the application is doing with our data, but actually comparing and contrasting that to knowing what data has been processed, right? And so, 80, 90% of the time, many times it's the data that makes our microservices go for a toss. And having that factual evidence and context of what data has been processed over a given period of time proves extremely valuable to be able to quickly know exactly why and how to reproduce an issue very quickly. All right. The next level that I think many folks are intimately familiar with is getting into logging information. So point number 5 here, Alex, is to be able to find true root causes is many individuals, as Dave had mentioned, to be able to access log files.
Hey, Rich, just quickly before we move on to the next point, we had a question from the audience here is, how does this kind of relate to Kubernetes? Is Kubernetes making the problem difficult? Because a lot of these things are also relevant for other types of applications.
Yeah, so just as Dave described earlier, the proliferation of services and let's just take logging as an example, right? If you have dozens or hundreds of services logging in different areas, being able to access all of this information can provide to be pretty manual, right? many organizations have delineation of responsibilities, and they don't have access to all this. And so there's a necessity to bring in additional resources to find some level of this information, right? And so when we think about what Dave was describing and the proliferation of different technologies and the tools necessary to help drive efficiencies and automations when managing applications inside of a Kubernetes cluster or microservices architecture, that can become pretty complex, right? It's not all in one tidy little location typically. There's many steps and necessity to go into different tools and to bring in different resources to begin to collect all of this type of information to get context of what is causing the issue inside of an application.
Thanks, Rich. That's a really good answer. Right, let's move on to the next part.
Yeah, so I don't think I need to spend a whole lot of time here. I suspect most of us are intimately familiar with the necessity to go into logs, right? Whether that be, grepping logs manually, whether that be in a Kubernetes cluster, indexing all of this logging information inside of Splunk, and then utilizing keyword searches and regex and what have you to search inside of log files and find log statements that give clues as to what sequence of events had occurred inside of our application. And I think this is what most of us are familiar with, and to be able to try and investigate what is going on inside of the application. The challenge of this is being able to appreciate more context. Unfortunately, these logging statements typically don't have enough information, but it's certainly part of the process and certainly something that as a development team, when troubleshooting, is typically one of our first go-tos, right? To be able to try to find, again, more context about why the error had occurred. Okay. This one's interesting to me in that, container variables and understanding environmental information inside a container can provide to be quite challenging when we think about containers running inside of Kubernetes. Many times if the application goes for a toss, the container might be shut down, and then maybe something's written to the log, maybe it's not. But if I go into the log file, or trying to access a container, it may be impossible because a container may have gone down and shut down completely. And then being able to find that context of various environmental variables, what the state of the container looked like at time of error, can prove to become extremely valuable. Sometimes very similar to data can cause the application to go for a toss. Many times it's the setup of the container itself, right? And variables and what have you. Maybe it's pointing to a wrong environment, right? Going from, moving from, QA or user acceptance testing into production, and we missed that as part of our testing as an example, right? But in a Kubernetes type environment where containers are, come up and come down, sometimes it might be impossible to find this type of information. But on the flip side, to be able to understand that data provides to be invaluable context to be able to help reproduce and fix the issue much faster. Okay. And so the last one I think is of high interest is understanding historical context of the error and historical context of your microservices in the cluster. So for instance, I think it would be pretty interesting to know, what code has changed recently. Has anything been committed recently inside of, these set of services that would potentially spawn an issue? What about analytics about the error itself? How often is this particular error occurring? And does it happen for every single transaction, or is it an anomaly and it only happens, less than 1%? those types of contexts would provide to become invaluable, just to, again, provide that information to understand and give development teams much more laser focus to be able to focus my time and effort as a developer and as a development team. Again, all about being more productive and more efficient.
Perfect.
So,
thanks, Rick.
Yeah, so generally speaking, Alex, these are the 7 areas that I think can be challenging, as we described before. Being able to find these in a complex environment with dozens of or hundreds or more services can become challenging. And but nonetheless, I think these are the 7 things that would become valuable to resolving these much quicker.
Perfect, thanks. There's actually a question that I want to ask Dave that kind of ties to it. So in the monolith world where it was just one application, everything was kind of centralized in one place, and with especially with Kubernetes-based applications where there could be tens, hundreds of microservices with that are deployed. How do things like versioning come into play and tie into these things?
Yeah, that's a good question. And really, I mean, automation is really your friend here. So a CI/CD pipeline where you can build your code, test your code, and then deploy into a lower environment is key. And oftentimes people use what are called blue-green deployments, or they'll actually do a rolling deploy of, here's the new code for a fraction of our customers, and everybody else stays on the old code, and you can kind of monitor and see what's happening to that new code. So it's really important to use those automated tools. This is things like Jenkins to sort of handle that in an automated way. And really do those instead of rolling out everything at once, right? Monolith, here's the upgrade. It's nice to do a slower deploy of just a few services, and that's one of the benefits actually of using Kubernetes in this cluster environment, is that you can have multiple versions of the same service running in the same cluster at the same time.
Got it. So multiple versions of the same microservice can be running at the same time, and that's also where a lot of the data that Rich just presented could be useful to kind of really understand which specific microservice that issue is coming from. If it's happening in one of them and not in the other, you just need a lot of data that you wouldn't necessarily need in a simpler type of deployment, it sounds like. All right.
Yeah, and it's important to have the
thanks.
annotations too, right? So that way, if you actually label your deployments and label everything, it's important to have that information so that you're able to figure that out.
Yeah. Thanks. And I will move on to the next part of the presentation, and let me pass over the controls to you, Rich.
Okay.
Just a second. Here we go.
Okay. Let me show my screen here. Yeah.
So in the next part of this webinar, we're going to talk about how OverOps fits into this equation. We just recently announced support for Kubernetes-based applications, and Rich is going to kind of walk us through those new capabilities that we offer for Kubernetes.
All right, thanks, Alex. Let me pass it back to you real quick. I'm not having a pop-up here. 1 second.
No, it's okay. So while Rich is kind of setting up his environment, as we mentioned, this is a live webinar, so all the issues that we're going to run into are happening in real time. But if anyone has any more questions that they'd like to ask, we can address a few of them now. So Yeah. Let's see. Oh, okay. Looks like Rich is back.
Yep. Had too many screens up on my side. So you can see my screen?
Yes. Okay. So we'll move the questions to the last part of the webinar, and let's move on with the demo from Rich. Cool.
Okay. So when I first started speaking, guys, I was talking about how we could identify some of these critical errors, and I want to get into the bonus that I was describing, or that I had teased at the beginning. And that bonus is really about getting access or being alerted to only those errors and exceptions that are critical inside of your Kubernetes cluster. Now, one thing that that we hear over and over is getting alerts can become noisy, and to some degree being so overwhelming that to some degree they even get ignored. And unfortunately, that tends to lead to customers complaining and customers calling in to report the issues, which doesn't put development teams and the owners of the applications in a great light, right? And so one thing that I want to describe it with OverOps is what you see here is an alert in which it is quite a bit differentiates and helps to minimize some of that noise that I described. So what we're looking at here is actually an alert from one of our microservices inside of Kubernetes in which a new exception had occurred. Now this is interesting because OverOps understands and sees the code that's running. It can actually tell me when a new exception is occurring. And so at that point, send an alert. And probably even more interesting, it'd only send me one alert. So now that I have greatly potentially reduced that noise by not receiving dozens or hundreds of alerts for the same error, okay? But now if I play that forward, just in this alert alone, we have some of that level of context of those 7 elements that I described. So anything from understanding this particular exception occurred within a particular container or server, which microservice was contributing to this error, or which one did it occur in. Just kind of parlaying what you, Alex, and Dave were describing, being able to identify which deployment introduced this new exception. Most certainly with a understanding what the error exception is, the location, along with that execution path for that stack trace that we talked about. Now, I think probably more interesting than that is having some of that historical context. Remember, I think our 7th bullet point, our 7th element, was understanding historical context. So giving a developer information about what methods had changed recently, again, gives that information and gives a little bit more of a laser focus on where to focus our time, where to focus our attention, so that we can get this resolved quicker. Okay, so this is kind of that bonus, if you will, to get to reduce that alert noise and to give something that is valuable from a critical alert perspective. But then if I play it forward and kind of how this process would work is with OverOps to be able to provide the level of those 7 elements that we described earlier in one nice little package in a fully automated fashion. All right. So what we're looking at here is all of the context of those 7 elements that a development team and a developer would need to quickly reproduce this exception, reproduce the issue, and so they can quickly move on to fixing it and move on to building new features and function. So it really is about automating that process. And so when we think about those elements, play it forward, we talked about versions and when this particular exception was new, right? Which microservice was it a part of? In this case, it's our collector server application. 4.426 introduced this particular exception. Now for this SQL exception, we have our stack trace, and most certainly that's typically the first thing that we find. But again, that historical context that this code had actually been modified very recently. So Alex, earlier you were asking me a little bit more detail about the running code. And so nothing is more valuable to understand right in my face what the code is actually doing at that time of exception, right? And so here's the actual code, frame over frame, that was being run at the time of the exception. But I think most interestingly of all is being able to appreciate the data that was being processed inside of this application. All right, so as I begin to investigate further within this stack, we can actually see the data that was being processed. So again, as a developer, I have the context of the data that was being processed, and in this case, looking at a prepared SQL statement. Because we had a SQL exception, we can actually see the data that was being passed from service to service and have undeniable evidence of what actually occurred inside of our applications inside of Kubernetes, so that we can have, identify, actions forward to getting this thing fixed much quicker. And again, spending more time building new features inside of your Kubernetes applications as opposed to troubleshooting it.
Yeah, thanks for addressing this, Rich.
Absolutely. So one other thing I want to talk about of those 7 aspects, understanding the environmental information, as we described, with applications that come up and down and containers that, potentially crash due to application errors and what have you. Some of this information from an environmental standpoint could be impossible to achieve. With OverOps, we will be able to collect at that time of exception what the environment looked like inside that container. So anything from memory to garbage collection, environmental variables, right? What if we have an environmental set that is wrong? Well, in typical traditional methods, if it wasn't written to a log somewhere and the container's not available, then we would just be left simply guessing. And so this is just an example of how we can collect and provide this evidence to the development team and really help minimize the chaos and the blame game, but rather provide factual evidence, get on to fixing the issue.
That's cool. Okay. Thanks, Rich.
Yeah. So I tell you what, Alex, go ahead.
Yeah, sorry. So you mentioned a lot of things from the developer standpoint with the variables. So how would someone that's more in the DevOps or operations side of things would use this data?
Yes. So one thing that might be interesting to this is, again, going back to that bonus, identifying critical errors and exceptions, and being able to identify these and with intention to prevent its impact to users, right? And then, being able to measure the level of critical errors and exceptions that could be introduced into your code base, right? So just one example of this, Alex, we have, quite a bit of analytics inside of OverOps that we can provide. So obviously I won't be able to show all of that, but I just want to give you a sneak peek into something such as this that you see here. And I'm looking at a trend of all of our services inside of Kubernetes and breaking it down into, one example is new exceptions that have been introduced through our code, right? And through our deployments. So I can actually see for these particular services that are running on Kubernetes, the number of exceptions in the applications, including ones that would never be written in the logs, like uncaught exceptions or unhandled exceptions, or maybe swallowed exceptions that in which there was a try catch ignore so nothing was found in a log, right? So an example of that is looking at something such as this, or for instance, breaking it down to other measurable capabilities because of all the context that OverOps can collect, being able to describe which ones are more severe new errors, or maybe identifying slowdowns, or breaking it down and scoring and measuring your application based on certain analytics as well. So these are all various ways that we can analyze the quality of our code, how we are delivering, and if whether or not we're improving. Release over release is another example. If I look at my particular line trend chart here on the bottom, and I'm dating back, 30 or so days here, we can actually see just after 10.18, we introduced a version of our various applications, 4.44.3. And with that being said, we can quickly see over a given period of time, that middle of the night, we actually introduced some new errors and exceptions into this. And so from an alerting perspective, we can imagine being able to know very quickly when these particular exceptions had occurred, be notified immediately, and know exactly what's happened with all of the 7 elements of context that we described before, right? So this is just one example of how we can measure trending and score our releases and score our code and how we're delivering that information by measuring against, very informative metrics, whether that be new errors, critical errors, slowdowns, so on and so forth.
Thanks. And Rich, is there a way that people on this call could play around with this environment?
Yeah, we do actually. So we have a sandbox environment, if you will, that you can actually work through this data yourself. So that is demo.overops.com. And actually what you're seeing right here is that data in action as well. So you can actually see and feel and touch everything that you saw here today on your own and experience those 7 elements that we described.
Perfect. Thanks, Rich. Yeah, so thanks so much, Rich and Dave, for sharing your knowledge with everyone in this webinar. So yeah, all the data that you're seeing here, this entire demo is available on demo.overops.com, and that the demo environment is actually monitoring Kubernetes based application that Dave, that's here on the call, helped create the infrastructure for. And just as a quick reminder, so we're also going to be in KubeCon next week in San Diego. So stop by the booth for some swag and chat with our engineers. We'd be happy to meet you in person, and we'll send everyone on this webinar the links to everything that was mentioned, and the slides, the recording, and a few more resources that would help you to get started with OverOps and Kubernetes. So thanks everyone, and we hope you enjoyed this webinar. Have a good rest of your day. Thank you.